All right, so let's run through a little periodic table recap. This is not meant to replace going through all of the problem-based learning stuff and all the things we're doing in class, but it's kind of nice, I think, to have a little recap. So we'll do that this way. So this is a dynamic periodic table. A couple kind of cool things about this. If it's just something you might want to explore, I can grab this little temperature bar and I can be, hey, look, I can make colors. But what we're actually doing, right? If I make it cold, right, it'll show that pretty much everything is a solid, right? You look at how it's all black down here at these really cold temperatures at negative 246 degrees Celsius. As I warm it up, more of those become liquids and gases, right? If we get it hot enough, right, we can make everything a gas, right? So any element is going to have a solid, liquid, gas form. But anyway, we can look at it a few different ways. We can, where's the wide view? Here's wide view, right? This is really what our periodic chart should look like. Right? You can see it insert there. This is just really inconvenient, right? It does not fit on a nice piece of paper like it is, right? So we pull these lanthanides and actinides, right? Look at that, I can make it highlight, lanthanides and actinides. We can pull those out and still get the basic use, because most things are in this top section of the periodic table, because everything up to iron can get made in a regular star. Everything bigger than iron has to get made in a supernova. So what you really see the numbers drop after iron. That's one of the reasons there's quite a bit of iron, right? And it's easy to find iron. But the main metals, like in the crust of the earth, are right, like aluminum and iron. Those are small metals. You don't see tons of gold and tons of platinum and tons of tungsten, right? They're there, but not as much. So anyway, right? So just if we kind of run through the big chunks on the periodic table, we've got our metals. That's pretty much the left side of the periodic table. Then we have our non-metals, which is this little chunk in the middle here. They're kind of like metals, kind of like non-metals. Tin is a nice example of a metal that's right next to the metalloids. So actually, when tin is warm, it acts like a metal. But if it gets cold enough, it's no longer malleable, right? It can't be flattened into a sheet. It becomes brittle. So back in the 1500s, there was a very cold snap in Germany that made... they got really, really cold, and the tin that they made the organs out of got cold enough that it actually got brittle, and when they would play the organ, it exploded a lot of the organs. So it turned tin from being a metal into acting a little more like a metalloid, right? You see it right there next to the metalloids. If I can do this, well, I can't point on my screen, but you see SN, right? Number 50, it's right there next to germanium. And then we've got our nonmetals that are over here on the right side of the periodic table. We've got our alkali metals. That is the first column. That's all of our really reactive metals. They only have, how many valence electrons do they have? They have one, right? They have one valence electron, so that makes them pretty reactive. They can lose that electron pretty easily, so they react pretty readily. You have your alkaline earth metals. They have two valence electrons, so they are also pretty reactive, but not quite as reactive because they have to lose two electrons, so it's a little bit harder for them to react. You have your transition metals here. You have your post-transition metals over here. And then you have your noble gases. They don't have halogens on here. I wonder why they don't have halogens. The halogens is this column right here. I don't know if enough has been done with this 117 to know if it really fits with the halogens, because really a lot of people say that astatine doesn't even fit 100% with the halogens. But it's this last column here for the halogens. Those are a pretty commonly named one too. And so that's like our basics. Right? That's the families and stuff. Right? Then rows, right? Our rows are the horizontal sections. Those all have the same number of energy levels. Let's see if we can find orbitals on here. Right? Electrons. Yeah. So if we go like this, right? We are in the fourth energy level here. You can see that the electrons are filled in the middle there. So we've got the fourth energy level and the fourth level, the third energy level, the second energy level, the first energy level. If we're way down here to francium, we're in 7 energy levels. Whereas the columns tell us the valence electrons. So you've got one valence electron here, two right here. Notice they moved helium over here to fit with the S block for this one. Then you have 3 valence electrons, 4, 5, 6, 7, and 8 valence electrons. Let's see, I don't know if we can do that. I don't think we can show that. So anyway, right, so the columns there are our valence electrons. The groups are our valence electrons, but you skip those transition metals. So you go 1, 2, 3, 4, 5, 6, 7, and 8. Right? Hopefully that is helpful as a reminder on your basics for the periodic chart.